Welcome to Hamsterville. It's a highly intricate, densely packed miniature city constructed out of cardboard, facing the threat of a simulated tea-light inferno. High-density paper architecture combined with open flame creates an immediate disaster risk. A single spark will spread across these dry materials, and human hands are too large to reach into these tiny streets to extinguish the flames without crushing the buildings in the process. To navigate these tiny alleys, we have to scale down our equipment. Enter a custom-built miniature fire engine, complete with structural reinforcements and an exterior layout designed for a micro-environment. Looking at this cutaway schematic, you can see the miniaturized water tank housed directly inside the chassis. It is connected to a remote-activated, high-pressure motorized pump system designed to push liquid out at maximum velocity. Matter of fact, delivering heavy volume of water into a fragile space requires a machine small enough to clear the walls, but heavy enough to hold a payload. This highly specific engineering setup is the only way to save the infrastructure without destroying it. But a machine needs an operator. Meet our pilot, a 4-inch-tall rodent recruit with built-in cheek pouches and a low center of gravity. Operating complex machinery requires behavioral conditioning. We use operant conditioning to train the pilot. Every time they execute a specific steering motion, they receive an immediate food reward, building a direct neurological link between driving and snacking. Before stepping into the cab, the pilot runs a snack-motivated obstacle course. Navigating these physical puzzles tightens their reflexes and proves they can make rapid directional choices under pressure. This force vector analysis maps out the exact amount of torque a tiny paw can generate. Standard mechanisms are too stiff, so the vehicle's steering wheel is custom calibrated to match the specific weight and grip strength of our pilot. Mechanical engineering sits idle if the operator can't react. Navigating a crisis requires an instinct-driven, perfectly conditioned pilot at the helm. The alarm sounds. The fire engine drops its ramp and immediately deploys from the docking station into the field. The pilot aggressively navigates into the grid. The paper alleyways are twisting, extremely narrow, and leave almost zero clearance on either side of the heavy truck. Localized smoke machines kick in. Simulated flare-ups burst along the primary route, heavily obstructing the pilot's line of sight and masking the upcoming corners. This animated cross-section details a massive physics challenge: slosh dynamics. The shifting liquid payload violently pushes the vehicle's center of mass outward. If that momentum tilts the truck past this exact tipping point, liquid gravity overcomes the wheelbase and the apparatus rolls over. The pilot balances the momentum, arriving at the first hotspot. Then the high-pressure nozzle forcefully deploys, splashing violently against the smoldering cardboard wall and instantly killing the heat. Loud noises and flashing lights usually trigger a rodent's biological urge to freeze or hide. Surviving this chaotic first engagement proves the pilot can suppress prey panic and rely on conditioned training. The situation shifts. The simulated fire has unexpectedly climbed upwards, taking hold of a taller, multi-story cardboard structure. Suddenly, the vehicle stalls. Forward momentum completely halts, trapping the pilot underneath the flames. This geometric trajectory line maps the new challenge. To hit that second-story target Mendo from the ground, the Hamster must reverse the truck and recalibrate its position to perfectly match the arc of water pressure. Reversing to adjust an angle of attack requires real-time spatial awareness. The pilot is calculating a new firing position to clear the vertical obstacle. The truck pushes into the city center. The final and most vulnerable target is the intricately designed miniature bakery, which is currently enduring the heaviest flames. Two compounding physical barriers block the final approach. Scattered simulated debris litters the road, and ground-level runoff water is pooling, severely reducing tire traction. The pilot executes a high-stakes steering maneuver to aggressively steer around the blocks, fighting for grip while simultaneously operating the hydraulic pump controls. The nozzle aligns. The system hits maximum water output, striking the target dead on and fully extinguishing the largest flames at the bakery doors. Threading a slippery, debris-filled course while managing a high-pressure water cannon requires a seamless link between biological instinct and human-engineered hydraulic power. The tension breaks. The cardboard landscape is doused, dripping wet and completely silent. Thermal scans confirm total neutralization of all localized hotspots. The paper walls are soggy, but the structural architecture of Hamsterville survives intact. The fire engine safely returns to the docking station. The pilot hops out for a celebratory post-mission weigh-in, earning a specialized top-tier seed reward. By bridging the gap between rodent biology and industrial-grade hydraulics, the pilot has turned a series of rewards into a functioning rescue operation. The next machine is simply a matter of scaling the controls.